Goofy little critters who would bounce off cliffs and glide down to safety by steering their big flaps of skin like a makeshift parachute. While these little lizard people are entirely fictional, they're actually based on a group of real animals that lived 300 million years ago during the early days of tetrapods or four-footed vertebrates. But did these ancestors of snakes and lizards really use their flaps to glide? And if so, were they the first vertebrates to take to the skies? It turns out it's complicated. So what exactly are we talking about here? We're talking about a group of extinct reptiles called the Cenozoic, which lived from around 323 to 299 million years ago. These guys were some of the first reptiles to leave the water and make their way onto land. Some were small, some were huge, but all shared one key feature, a pair of limbs near their shoulders that were adapted into wings made of skin and bone, kind of like the wings of a bird or an insect. See, this is where things get weird, because for a long time, scientists weren't even sure if the cynodonts were actually related to modern reptiles like snakes and lizards. Their shoulder girdle, or the bones connecting their limbs to their body, was so different from other reptiles that it didn't fit the traditional reptile body plan. So the cynodonts were classified as a group all their own, separate from other reptiles like turtles, snakes, and lizards. But recent studies have revealed that this is like, nah. They're definitely more closely related to modern squamates, the group that includes lizards and snakes than other early reptiles. Now, this doesn't mean that birds are related to snakes and lizards. The two groups just share a more recent common ancestor than they do with other early reptiles like the ancestors of turtles. And when you look at the fossil record, the story only gets weirder. One of the most famous cynodont fossils comes from a species named Cenothops fricki. And as far as we can tell, it was completely flightless. It couldn't fly at all, yet it still had a pair of wings. So why would a flightless animal need wings? Well, scientists think they may have helped the animal balance itself as it walked. This idea is supported by the fact that many modern lizards also have little flaps of skin next to their forelimbs, although those aren't as elaborate as the wings of cynodonts. Other cynodonts, like the aptly named sprawled beast, looked like they could fly, and maybe they could, but probably they used their wings for something else. Take a look at their skeletons, and you'll see that their ribs were longer in front of their shoulder blades than behind them. And this made their chest cavity bigger in front, which would have made it hard to breathe efficiently. To compensate, they evolved a special ribcage configuration that allowed them to expand their bellies sideways, giving them more space for air sacs connected to their lungs. Now, this type of breathing is pretty common among modern birds, but it's extremely rare in reptiles. In fact, there's only one other known reptile that has this belly-breathing adaptation, the tuatara, a type of lizard found only in New Zealand. Plus, cynodonts had feathers. Okay, not bird feathers, more like downy fuzz, but feathers nonetheless. They were probably used for insulation, and may have helped these animals regulate their body temperature, kind of like modern lizards do. All this evidence suggests that the ancestors of cynodonts were aquatic, maybe even more so than snakes are today. They likely spent a lot of time in the water, but occasionally came up for air. Maybe they were awkwardly shuffling along the shoreline looking for fish to eat, kind of like today's marine iguanas. But if cynodonts were awkward landlubbers, how did they evolve wings? If you look at the limb bones of cynodonts, especially the bones in their hands, feet, and wings, you can tell they come from very different ancestors than the limbs of other reptiles, mammals, and birds. The bones in their wings don't match the bones in their feet, which means they evolved separately from the other limbs. This tells us that these guys didn't just crawl up on land and grow wings. That would imply that their limbs all evolved at the same time. Instead, their wings evolved separately, suggesting that they developed in the water, maybe even on fish hunting expeditions. But wait, wings usually help animals fly. Did early whales also evolve paddles before they became fully aquatic? Not quite. You see, cynodont limbs had a very particular arrangement of bones that gave them a flexible wrist joint. Unlike modern reptiles whose wrists are rigid, this flexibility would have given them more control over their limbs in the water, helping them swim efficiently and maybe even maneuver in tight spaces like between rocks or under logs. Swimming efficiently would have been super important for animals that spend a lot of time in the water, and maneuvering in tight spaces would have been useful for hunting fish. So it makes sense that this type of wrist would have been advantageous for early tetrapods trying to adapt to life both in and out of the water. So does this mean they glided? Some researchers think the flexible wrists alone would have been enough to let these animals glide through the water, basically letting them walk on water. We're not sure how well they could do this though. Others have pointed out that their wings, especially those of larger species, seem to have been good for gliding through the air. So it seems plausible that our flying lizard people ancestors spent more time in the sky than on the ground. But we'll need more evidence to figure out if they really glided. So while scientists work to solve this mystery, they've also been working to piece together the evolutionary history of birds. As you might have guessed, the earliest ancestors of birds looked nothing like hummingbirds or Galapagos. Instead, they were small, feathered dinosaurs that lived in what is now China about 230 million years ago. But after that, the fossil record gets a little fuzzy. For a long time, paleontologists had no idea what the immediate relatives of birds looked like or how they were related to dinosaurs. But in 2022, a new discovery shed some light on these early avians. A fossil found in southern China pushed back the origin of birds by 10 million years, and it showed that the oldest known bird relative had feathers covering its entire body, including its legs and feet. It also had a wishbone, which is a fused pair of bones that helps support a bird's chest and power its flight. But this bird-like dino wasn't technically a bird because it didn't have the right skeletal features to fly, so it was probably a glider. This means that birds weren't the first vertebrates to evolve wings, because those would have appeared first in the cynodonts around 100 million years earlier. But it also means that they didn't have to evolve wings first either. They could learn to fly without them. Take a look at any bird skeleton, and you'll see that most of their wings are made of hollow, lightweight bones. These bones are super strong too. If they were scaled up to human size, they could support a human jumping over a house. But obviously birds aren't huge, so they don't need that much support. In fact, they're perfectly sized for their wings, so it makes sense that they didn't need wings to glide through the water first. Instead, they probably used feathers to help them balance as they walked, kind of like modern lizards do, then took to the skies with their bony wings. That said, birds aren't the only vertebrates that can fly without wings. Flying fish also glide through the air, thanks to their large pectoral fins. And we already mentioned gliding lizards, which are actually descended from flying snakes. Okay, they're not technically a different species. Scientists just observed that when snakes fall from a tree, they orient themselves vertically and flatten their bodies to glide through the air more efficiently. This behavior has evolved multiple times in squamates, the group that includes lizards and snakes, and it has nothing to do with their wings. So when it comes to taking flight, looks like evolution has had a few tricks up its sleeve. Who knows? Maybe in another 300 million years, we'll be sharing the skies with gliding snakes and lizards, except this time, they'll have scaly wings like a bat, or maybe feathered ones like a bird. Or maybe they'll evolve giant, stretchy skin flaps and turn into lizard people. Oh man, I hope they don't turn into lizard people. That movie was terrible. Thanks for watching.